Hello students, so your midterm chemistry examination is approaching for some students. So in today's video we are going to discuss the most expected numericals from physical chemistry that can be asked in your midterm examination. Now see, you know, in the part E there will be 6 numericals, out of which you need to appear any 4, you need to attempt any 4. So definitely these questions in your final board will be distributed like 2 from physical, like 2 from solutions, 2 from kinetics and 2 from electrochemistry, right? So because our midterm portion is about solutions and electrochemistry, so I have collected around 10 to 15 numericals, most expected one from both of these chapters, that is solutions and electrochemistry, and I'll be telling you detailed step-by-step method how you should solve them, how you should present them in your answer so that you can get 3 out of 3 in all these numerical questions. Okay, please remember this is the most scoring part because you have calculator, so there is no error, like there should not be any error in calculation. The only thing is correct knowing proper presentation and putting correct values and knowing the formulas and understanding the question. Okay, so now let's get started with the first one. So we have 2 chapters here, as I told you. We'll discuss from solutions chapter. So from solutions chapter, numericals will be there in the 3 marker question, right? One of understanding type and one of HOTS type. Okay, 2 numericals we can expect. So now let us see the first question here. 450 centimeter cube of an aqueous solution of a protein contains 1 gram of protein. Okay, now before going to this question, I want to tell you something like what are the different topics from where you can expect numerical from this particular chapter. First is your Henry's law numerical you can get. Okay, Henry's law. Second, you can get from Raoult's law. Okay, next you can get from colligative properties. Okay, all the 4 colligative properties, right? That is your elevation in boiling point, then you have depression in freezing point, then you have osmotic pressure, and then relative lowering of vapor pressure. And next one will be related to this colligative properties only, but using Van 't Hoff factor. Okay, so these are the probable questions or probable sectors from where you can get the numericals. Okay, now let us go to this question. 450 centimeter cube of an aqueous solution of a protein contains 1 gram of the protein. The osmotic pressure of such a solution at 310 Kelvin is found to be 3.1 into 10 to the power of minus 4 bar. Calculate the molar mass of the protein. Okay, so now you should remember whenever generally whenever questions from colligative properties are asked, you are most of the time asked to calculate the molecular mass. Okay, most of the time. Clear? So now in the same question here also molecular mass of the protein is asked. Now while solving any numerical question, you need to follow 3 steps. First step is to write the given data. Okay, first step is to write the given data. Now see, this step does not carry any mark, but it is very important so that you solve the question correctly. So please do not miss this step. Okay, now second step is to write the formula. Okay, this carries 1 mark. Next, third one, to do correct substitution. Okay, this carries 1 mark. And fourth one is to write the answer with units. Okay, and remember to make a box with this answer. This will carry 1 mark. Okay, so we have 4 steps and marks will be given for these 3 steps. Okay, now let us write down. So what is our step number 1? We'll write the given data. Okay, so I'll start the question from here. Okay, so given data. 450 centimeter cube of an aqueous solution. So that is volume, right? So volume given is 450 centimeter cube. I can write 450 ml. Of a protein contains 1 gram of a protein. So that is the mass of the solute. W2 is 1 gram. Here you should remember 2 represents solute and 1 represents solvent. The osmotic pressure at 310 Kelvin. So temperature given is 310 Kelvin and osmotic pressure given is 3.1 into 10 to the power of minus 4 bar. Okay, and calculate the molar mass. R value is given to you, 0.083 liter ATM mole inverse Kelvin inverse, right? Liter bar is taken, sorry, liter bar mole inverse Kelvin inverse. Okay, so step 1 is over, that is writing the given values. Now what is the step 2? To write the formula that is required here. So second formula, so I am just writing here step 2, I will write pi is equal to molarity C into RT, so W2 by M2 into 1000 by volume into R into T. Okay, now what is the next step? To do correct substitution, so what is the pi value? Pi value is 3.1 into 10 to the power of minus 4. Then W2 value is 1 gram, molar mass we need to calculate, into 1000 by volume is 450. Okay, R is 0.083, right, 0.083. Then temperature is 310 Kelvin. Okay, so now once you solve this, we can calculate the value of M2 from here. Just put it in the calculator, all the values correctly, and then you will be getting answer as something around 18,000, sorry, you can say 1,84,444 gram per mole. Okay, just check the calculation, but this should be your step number 1. This should be, this will carry you 1 mark, this will carry you 1 mark, and this will carry you 1 mark. Okay, calculation, just put in the calculator correctly and solve the question. Okay, next question. This question was asked in May 2023. Now 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of given of benzene by 0.4 Kelvin. Okay, the freezing point depression constant is given this much and the molar mass of the solute. So again you can see question is asked from the molar mass, right? So let us write 1 gram. So what is this one? Given value, step number 1 I am doing. Given value is W2, that is 1 gram. Okay, dissolved in 50 gram of benzene, so W1, that is mass of the solvent, is 50 gram. Okay, lowered the freezing point of benzene by 0.4, that is delta TF is 0.4 Kelvin. Okay, the freezing point depression constant, that is KF, is 5.12 Kelvin kilogram mole inverse. Okay, the molar mass of the solute we need to find. So step 1 is over. Next step 2 is to write the formula. So we know delta TF is equal to KF into molality. What's the molality? W2 by M2 into 1000 by W1. Okay, next one what we need to do? We need to do correct substitution. So what is delta TF? 0.4, KF is 5.12. Okay, W2 is 1 gram, M2 we need to find 1000, and W1, that is mass of the solvent, is 50. Okay, so this is your step number 2. Sorry, correct substitution is done. Now what you have to do? You have to just do the calculation here and you need to find the value of M2, that is 256 gram per mole. So I hope you can do the calculation by your own and check the answer, but substitution should be done correctly here. Okay, 256 gram per mole. Okay, now let us see the next question here. Okay, question number 3. On dissolving 3.46 gram of non-volatile solute in 100 gram of water, the boiling point of solution was raised to that of pure water by 0.12 Kelvin. Calculate the molar mass of the non-volatile solute. Again it is molar mass given. Okay, Kb of water is given to you. Question was asked in March 2022. So let us write the given values once again. So what is W1? W1 is, sorry, W2, mass of the solvent is 3.46 gram. Okay, next if you have mass of the solvent, that is 100 gram. Okay, boiling point of the solution, that is delta TB, is 0.12 Kelvin. Okay, and then Kb value is given to you, that is 0.51 Kelvin kilogram mole inverse. Okay, then this one. Now we need to calculate the molar mass of the solute. So let us first write down the formula. Delta TB is equal to Kb into M, that is W2 by M2 into 1000, okay, by mass of the mass, so that is W1, right? So now we need to substitute the correct values. What is delta TB? 0.12, Kb value is 0.51, W2 is 3.46 gram. Okay, then you have W1, sorry, M2 we need to find into 1000, okay, by W1 is 100 gram. Okay, now you can solve this and find the value of M2. So this will be your first step, this is second step, this is third step, and writing the correct answer with units and making it a box will be your fourth step. Clear, students? Are you getting these questions? Very easy, just you need to know 4 colligative properties formulas. Okay, now let us see the next question. Okay, 31 gram of an unknown molecular material is dissolved in 500 gram of water. Okay, the resulting solution freezes at 271.14 Kelvin. Calculate the molecular mass of the material. Same thing again, molecular mass based question. So first let us write the given values. So given values, first one 31 gram, that is your mass of the solvent. W2 is 31 gram. Okay, material is dissolved in 500 gram of water. W1 is 500 gram of water. The resulting solution freezes at 271.14 Kelvin. So what is this one? Delta TF. Sorry, TF is your 271.14 Kelvin. Okay. Then you have the KF value. KF value is 1.86 Kelvin kilogram mole inverse. Next we have T0F. T0F for mass value is 273 Kelvin. Okay, given this one, now what is the step to write the formula? Delta TF is equal to TF minus T0F. Okay, sorry, depression in freezing point, right? So freezing point of the solution will be less than the freezing point of the solvent. Okay, so here is equal to KF into M, again W2 by M2 into 1000, right, by W1. Substituted correctly. Now let us see, delta T0F is how much? T0F is 273 minus TF is 271.14, okay, is equal to KF. KF value is 1.86. Okay, molality W2 is 31, then M into 1000 by W1 500. Okay, now if we solve this, okay, you will be able to calculate the molecular mass and something around 62 gram per mole you will be getting. Okay, just check the calculation and see if you are getting the correct answer or not. Okay, now let us see the next question. So vapor pressure of benzene is 200 mm of Hg. Okay, when 2 gram of a non-volatile solute dissolved in 78 gram of benzene has a vapor pressure of 195 mm of Hg. Calculate the molar mass of the solute. Molar mass of benzene is 78 gram per mole. So this question has been asked from your relative lowering of vapor pressure. So first let us note down the given values. Okay, what is the given values here? Vapor pressure of pure benzene, that means P0 value is how much? 200 mm Hg. Okay, next, when 2 gram of a non-volatile solute, 2 gram, that is mass of the solvent, 2 gram is dissolved in 78 gram of benzene. So mass of the solvent is 78 gram. Okay, the vapor pressure now is 195 mm of Hg. So P is 195 mm Hg. Okay, now calculate the molar mass of the solute. Molar mass of benzene is given to you as 78. Okay, so first of all, here we need to do some pre-calculations, right? If you remember, RLVP is equal to XB, right? So we need to do the number of moles of benzene, we need to first calculate. Okay, so let us calculate number of moles of, sorry, one second, yeah, we have number of moles of benzene, that is what given mass my molar mass. So 78 by 78, that is equal to 1. Okay, now what will be the next? We need to calculate number of moles of the solute. What is the number of moles of the solute? Given mass by molar mass, which we need to find out. Okay, 2 by M2. So then what is the mole fraction of solute? We need to calculate the mole fraction of solute. So mole fraction of the solute will be 2 by M2 divided by 1, which is equal to 2 by M2. Okay, now we'll put the formula here. So we have delta P by P0 is equal to P0 by P by P0 is equal to XP. right? This is the formula. Now if I do correct substitution here, P naught value is how much? 200. Okay, P value is 195, P naught value is again 200, okay, into XB. XB is what? Number of moles of solute by number of moles of solvent. Okay, one second here. Yeah, here if you remember, if you see, XB formula will be equal to NB by NA plus NB, right? But generally in this type of questions you can ignore the number of moles of solute because it is very less as compared to the number of moles of the solvent. So we can eliminate this one. Okay, so we will get what? So XB, number of moles of this one is 2 by M2, right? Yeah, we have 2 by M2 divided by number of moles of benzene, that is 78 by 78, so that is 1. So with this you can easily solve for M2, right? So this is 5 by 200 is equal to 2 by M2. So M2 will be equal to 2 by 2 into 200 by 5. Okay, so you can solve, it is 5 4s are 20, will get 80 gram per mole. Okay, so correct answer is 80 gram per mole here. Got it? Next question. 5.8 gram of a non-volatile solute was dissolved in 100 gram of carbon disulfide. Okay, molar mass is 76 gram per mole. The vapor pressure of the solution was found to be 190 mm of Hg. Calculate the molecular mass of the solute. Similar question. Vapor pressure of pure carbon disulfide is 175. Molar mass of CS2 is 76 gram per mole. Okay, very similar question to the previous one. First we'll write the given datas. Okay, now non-volatile solute 5.8 gram. So what is that one? W2 is 5.8 grams. Okay, was dissolved in 100 gram of sulfide. So W1, that is your mass of the solvent, I can write CS2 is 100 gram of, 100 gram of CS2 is taken. Okay, molar mass is 76. Okay, so M of CS2 is 76. Next, the vapor pressure of the solution was found to be 190. So P is equal to 190 mm Hg. Okay, calculate the molecular mass of the solute. Vapor pressure of the pure carbon disulfide, that is P naught value is 195. P naught value is 195 mm Hg. Okay, molar mass of CS2 is done. Okay, so now again the same question. First you need to calculate the number of moles of solute. Number of moles of solute will be what? Given mass by molar mass, which we need to find. Next, number of moles of CS2, that is given mass by molar mass, so 100 by 76. So what is the number of moles, or I can say the mole fraction of CS2? So mole fraction of CS2 will be 5.8 by M2, right, divided by 100 by 76. Okay, so how can we write it in a simpler form? So this will be equal to 5.8 by M2, okay, into 100 by 76, right? Yeah, this is your XB. Now we can substitute here. Delta P by P naught is equal to P naught by P by P naught is equal to XB. So this is your formula. Now if you do correct substitution, 195 minus 190, okay, by 195, right? Pure pressure was 195, pressure of the solution was 190, divided by the pure pressure is equal to XB. XB value will be 5.8 by M2 into 76 by 100. Okay, now you can solve this question to find the value of M2. Okay, so this will give you around 171.91 gram per mole as the correct answer. Okay, very easy question. Next question, 300 centimeter cube of an aqueous solution of a protein contains 2.12 gram of the protein. The osmotic pressure of such a solution at 300 Kelvin is 3.89 into 10 to the power of minus 3 bar. Calculate the molar mass of the protein. So you see, whatever questions are asked from the colligative properties are asked to calculate the molar mass, right? So please practice such questions. This type of questions will be definitely asked in your exam. Okay. So first let us see the given values here. Okay. So what are the given values? First, volume. Volume is 300 centimeter cube. We can write 300 ml because 1 centimeter cube is 1 ml. Contains 2.12 gram of protein. So what is W2 here? 2.12 gram. Okay. Osmotic pressure of such a solution at 300 Kelvin. So temperature is 300 Kelvin and we have osmotic pressure of 3.89 into 10 to the power of minus 3 bar. Calculate the molar mass of the protein. We need to calculate the molar mass of the protein. Okay, R value is already given to you, that is 0.0823 liter bar mole inverse Kelvin inverse. Okay, so when you are writing the units, when you are writing the given data, make sure to write with units. Okay, while substitution you may leave the units, in the final answer you can write, but when you are writing the given data, write with units. Okay, so now we'll do the first step, that is substitution. Pi is equal to C into R into T, that is molarity. So we'll substitute the formula for molarity, W2 by M2, right, into 1000 by volume, okay, into R into T. So pi value is how much? 3.89 into 10 to the power of minus 3, clear? That is equal to W2 is how much? 2.12 gram. M2 we need to find into 1000 by volume is how much? Volume is 300. Okay, next 0.083, okay, 0.0823. 1 second, we have 0.0823 and 300 Kelvin, right? 300 Kelvin. So now if you solve this and get the value of M2, you will be getting around 44,852.4 gram per mole. So remember, molar mass unit is gram per mole. So whenever it is asked to calculate molar mass, units must be gram per mole. Okay, so that is done. Now we'll go to the next question. So this question was there in your blueprint. Okay, a 5% W by W solution of cane sugar C12H22O11 in water has a freezing point of 271 Kelvin. Calculate the freezing point depression constant. Given freezing point of pure water is this much. So this question is slightly different. It is not asking you about molar mass. Okay, something else is asked. Let us see. A 5% solution of W by W. First we'll write the given data. Okay, what is given data here? 5% W by W, okay, of cane sugar. Now what do you mean by this one? 5% W by W means 5 gram of solute is present in 100 gram of solution. Okay, so what I can write, what does this implies? This implies that 5 gram of, okay, cane sugar, solute is what? Cane sugar here. 5 gram of cane sugar is present in 100 gram of solution. Okay, so that means total solution mass is 100 gram and out of that 5 gram is cane sugar, right? So that is what is the mass of solvent here. We need the mass of solvent because we are dealing with freezing point formula, and freezing point formula has molality, and in molality we need the mass of solvent, right? So if the total mass of the solution, is total mass of the solution is 100 gram. Okay, now out of this 5 gram is your cane sugar, right? That means this 95 gram is your solvent, right? Total is 100 gram, 5 gram is sugar, then 95 gram will be solvent. So that is what you need to write here. Okay, so this is to this year's blueprint. So questions are not very easy like previous years, so you need to be little thoughtful here. So if you see here, what is there? Mass of the mass, 1 second, yeah, we'll write mass of the solute, that is W2, mass of the cane sugar is 5 gram, and W1, mass of the solvent is 95 gram. Okay, these two you should remember. Then freezing point of 271 Kelvin. So what is the TF here? 271 Kelvin. Next, cane sugar formula is given, so we can easily calculate the molar mass. M2 cane sugar, you should remember, it is 342 gram per mole. Okay, so you remember, whenever I am writing molar mass, the unit should be gram per mole. Okay, then you need to calculate what we have been given also with T naught F, that is 273.15 Kelvin. Okay, now we need to find what? Kf we need to find, that is your freezing point depression constant. Okay, so let us do now. What is the formula we have? Delta Tf is equal to T naught F minus Tf is equal to Kf into M. What is molality formula here? W2 by M2 into 1000, right, by W1, mass of the solvent. Now here we can substitute the values. What is T naught F? 273.15 minus what is Tf? 271 is equal to Kf. I need to calculate. W2 value is how much? W2 value is 5 gram. M2 value is 342 into 1000, right, by mass of the solvent is 95 gram. Okay, so now you just calculate, do the proper calculation and find the value of Kf. Okay, so if you do this calculation, you will be getting around 13.9. so units you need to write here, 13.9 kilogram kg mole inverse. Okay, clear? Okay, now we'll go to the next question. Okay, question number 9 is here. Henry's law constant for the molality of methane in benzene at 298 Kelvin is given to you. Henry's law constant at 298 Kelvin is given. Calculate the mole fraction of methane in benzene at 298 Kelvin under 760 mm of Hg. This is very direct question. What are the given datas? First let us note down. Given datas. First of all, we have Kh values. Henry's constant is 4.27 into 10 to the power of 5 mm Hg. Okay, next we need to calculate mole fraction. Okay, at pressure of 760 mm of Hg. So pressure given is 760 mm Hg. Okay, so now first write the formula. What we have? P of the gas is equal to Kh into mole fraction of the gas. I need what? X of the gas, so that will be equal to P of the gas by Kh value. So I'll substitute now, so that equals mole fraction of the gas will be equal to P of the gas. How much is P of the gas? 760, and Kh value is 4.27 into 10 to the power of 5. Okay, yeah, clear? Now if you solve this, we'll be getting around 1.78 into 10 to the power of minus 3. Okay, next question. Calculate the mass of vitamin C, that is ascorbic acid C6H8O6, to be dissolved in 78 gram of acetic acid to lower its melting point by 1.5 degrees Celsius, given the Kf is 3.9 kilogram Kelvin mole inverse. Okay, again similar question, but every time it was molar mass was asked. In this question, mass of the solute to be added is asked. Okay, so first let us see the given data here. See, first is ascorbic acid 78 gram, right? We need to calculate here W2. So first I'll write what is to be calculated. Molar mass we can calculate from the formula C6H8O6, right? So 12 into 6, we have here 12 into 6, then we have 8, and then we have 16 into 6, right? So this is 72, then we have 8 here, then we have 96 here. So I'll get 176, right? The molar mass is 176. So I'll erase this one and write the value directly. So this is 176 gram per mole. Okay, now to be dissolved in 78 gram of acetic acid. What is the 78 gram? That is your mass of solvent, 78 gram of acetic acid. So that to lower its melting point by 1.5 degrees Celsius. So what is your delta TF? Delta TF is 1.5. Okay, degree Celsius. And here you remember delta TF or delta TB value can be either in Kelvin or Celsius. You should not convert this one to Kelvin. Okay, 273 do not add here because this is a difference. Whether you take in centigrade or you take in Kelvin, the difference always remains the same. So this can be in centigrade also. Delta TF value I am telling, delta TF or delta TB value, the difference can be either in Kelvin or in Celsius. Okay, fine. So now we have next one is KF value here. KF value is 3.9 Kelvin kilogram and mole inverse. Okay, then okay, now let us start this one. We have the formula, we have delta TF is equal to KF into molality, that is W2 by M2 into 1000, right, by W1. Let us substitute now. What is delta TF? 1.5 degrees Celsius. KF value is 3.9, right. Next, W2 value is, we need to calculate molar mass. We already calculated 176 into 1000, okay, by W1 is 78. Now if I solve this and I want to find the W2 value, you will be getting the answer of 5.28. okay. So here you should remember that since we are calculating W2, that is not molar mass, the unit will not be grams per mole, unit will be gram. Only when you calculate molecular mass or molar mass, the unit should be gram per mole. Okay, fine. Next question here. Heptane and octane form an ideal solution. Okay, at ideal solution means they follow Raoult's law. That is what they want to indicate. At 373 Kelvin, the vapor pressure of the two liquid components are 105.2 kilopascal and 46.8 kilopascal respectively. Calculate the vapor pressure of a solution containing 26 gram of heptane and 35 gram of octane. Very easy question. So first let us note down the given data here. Okay, what is the given data? So Raoult's law question. Okay, we saw one Henry's law question, one Raoult's law question, and many colligative property questions. Okay, so now if you see what is the pressure of, so this, while taking these values, be very careful. Heptane data should be taken correctly, then octane data should be taken correctly. Okay, so we have the pressure of heptane. Heptane means C7H16, right? 7 2s are 14. We have alkane formula CnH2n plus 2. So that is your 105.2 Pascal, right? Kilopascal. 105.2 kilopascal. Next we have P naught of C octane. Octane will be 8. 8 2s are 16 plus 2 18. C8H18, and that is value is 46.8 kilopascal. Okay, clear this one. Now what is the mass of this one taken? W of C7H16 is how much? 26 gram. Okay, and W of C8H18 is how much? 35 gram. Okay, this is 25 gram and this is 35 gram. Next you want to calculate the molar mass of C7H16. Okay, what will be the molar mass? So just calculate 12 into 7, that is your 84. 84 plus 16. So 84 plus 10, 94. So that is your, we have C7H16, right? We'll calculate it correctly. 12 into 7 plus 16. So I have 84 plus 16. So that is 100. So this molar mass is 100 gram per mole. Okay. See students, you people will be having calculator, so easily you can do this calculation. I am little slow in calculation, so I am doing like this. Next we have, but be very careful, you can do little bit slow but do not be wrong. Okay. Now 12 into 8 here is 96, right? Then we have 18, right? So we have 104 gram. Okay, this is done. Okay. Now what I need? Now I need the mole fraction of each, right? Because you know the formula P naught A XA plus P naught B XB. So I need to calculate XA and XB. So now what I'll do? I'll do first the calculation of this one, that is mole fraction of, first we need to calculate number of moles. So number of moles of heptane. Number of moles of heptane will be given mass by molar mass. So given mass is 26, molar mass is 100. Right, given mass is 26, molar mass is 100, so I'll get 0.26. Okay, then N of octane, number of moles of octane, that will be how much? 35 by 104. Okay, so can we divide it? So now if you divide this, we'll be getting 0.336. Okay, you can just check in your calculation, 0.336 will get. Now I'll calculate what? Number of or mole fraction of heptane. Mole fraction of heptane will be equal to N of heptane, right, by N of heptane plus N of octane. Okay, so then we need to calculate, so now I'll substitute here. What is N of heptane? 0.26 by 0.26 plus 0.336. This one will give me 0.436. Okay, that is the mole fraction of heptane. Now from here we can calculate the mole fraction of octane. Mole fraction of octane will be 1 minus 0.436. So that will be 10 minus 6, 4, 9 minus 3, 6, 9 minus 5, that is 0.564. Okay, so we got these two values. Now you need to calculate here P total. P total will be equal to what? P naught A. Okay, so I'll write here the values. 1 second. So we have P naught of heptane into mole fraction of heptane plus P naught of octane into mole fraction of octane. Now if I substitute the values, what will be P naught of heptane? P naught of heptane is 105.2, right, 105.2. And what is mole fraction of heptane? That is 0.26, right. Next, P naught of octane is 46.8. And what is the mole fraction of octane? Mole fraction of octane is 0.564. Okay, I hope these values are correctly as substituted. Heptane 105.2A, and we have taken this one as 0.436, right? See, here I have done a mistake. Substitution, this is not number of moles, we need 0.436, okay, mole fraction. Then we have the 46.8 kilopascal and here 0.564. Okay, now if you solve this, you will be getting around 73.08 kilopascal. Please check the calculation once again, okay, and check all the values have been substituted correctly or not. Okay, now next question, calculate the molality of 20% W by V solution of Ki, given the density of this one and you have molar mass of Ki as 166 gram per mole. This is very important question, and the question is from the concentration term. Okay, blueprint question this one. Here you need to be very careful. See, molality of 20% W by V. W by V means what? 20 gram of solute in 100 ml of solution, right? So what I can write from this one, W2, mass of the solute is 20 gram, okay, and volume of the solution is how much? 100 ml. W by V represents given by mass of the solute in 100 ml of the solution. So I can say volume of the solution is 100 ml. Next, density is given to you. Density of the solution is 1.2 gram per ml. Okay. Next, molar mass of Ki is given. So M2, that is your solute, 166 gram per mole. We need to find molality. So if you remember, molality, we need what? In the molality formula, we need mass of the solvent, right? But here what we have? Here we have only volume of the solution. We do not have any information about the solvent, right? This is what? Volume of solution. This is what? Density of solution, right? So if you remember, here we'll do some pre-work, that is density is equal to mass by volume, right? So now I can calculate mass of solution by multiplying this one. So what is mass of the solution? That is equal to density of the solution into volume of solution, right? So density is 1.2 gram per ml, okay, and volume of the solution is 100 ml. So this one will get cancelled and I'll get 120 gram is the mass of the solution. In this solution, how much is the mass of the solute? 20 gram. Then what is the mass of the solvent? Mass of the solvent is equal to 120 gram, that is the mass of the solution, minus 20 gram, that is the mass of the solute. Now if I subtract this one, how much will get? 100 gram. We got now mass of the solvent, which is required for the formula of molality. Now we'll write the molality formula. Molarity is what? W2 by M2 into 1000, right, by 100. Sorry, I'll write the first formula into W1. Now substitute the values correctly. What is W2 value? Mass of the solute is 20, 166 into 1000 by W1. W1 is what? We just calculated, right? Mass of the solvent, 100 grams. So we have now, you need to calculate this one, 200 divided by 166. Okay, this will be giving you molality. You will be getting around 1.204 m. That is small m stands for molality. Clear? So this part is important to understand this conversion. Okay, fine. So next one question, vapor pressure of water at 293 Kelvin is 17.535 mm of Sg. Calculate the vapor pressure of water at 293 Kelvin when 25 gram of sugar glucose is dissolved in 450 gram of water. So relative lowering of vapor pressure, this is a question from there. Let us first write down the given data here. Okay, so given data, if you see, we have first of all the pure pressure. P naught value is 17.535. Okay, next you need to calculate P value. Okay, we need to calculate this P value. 25 gram of glucose is dissolved, so we have W2, that is 25 gram, and mass of the glucose is 180 gram. Okay, 450 gram of water, that is W1, 450 gram of water. Okay, these are the given values to you. And what is your M1? M1, since it is water, it is 18 gram. Okay, now what we need to calculate? We need to calculate relative lowering of vapor pressure. So for that we need first calculate the number of moles of glucose. Number of moles of glucose will be what? Given mass by molar mass. Okay, next number of moles of water. Number of moles of water will be what? Again given mass by molar mass. This is done. Next, if you want to calculate mole fraction of glucose, that is number of moles of glucose by number of moles of water. So here you should remember that number of moles of water is not considered, means it number of moles of glucose is not considered in this type of questions. So I can substitute number of moles of glucose is 25 by 180 and number of moles of water is 450 by 18. Okay, so now this is the thing that we got. Now we'll write the formula here. Delta P is equal to P naught by P by P naught is equal to XB. Okay, now I have the P naught value. P naught value is what? We have 17.535. Okay, minus P by 17.535 is equal to XV value will substitute here, that is 25 into 18 by 180 into 45, 450. Okay, so now solve this and find the value of P. You will be getting around 17.44 mm of Hg. Okay, clear? Fine. So with this we have practiced a lot of questions from solutions chapter. Now we'll go to the next chapter and do some numericals from electrochemistry chapter. Okay, so here if you see, you will be getting again two numericals. Okay, what are the formulas that you should remember here? First is your E naught for E naught of the cell, E naught of cathode minus E naught of anode. Next you have Nernst equation, E naught of the cell is equal to minus 0.59 by n log of product by reactant. Okay, that you should remember. Next, delta G formula is my NF E naught of the cell, delta G minus 2.303 RT log K, and then you have E naught of the cell is equal to 0.059 by n log K. These four formulas you should remember. Next we have Faraday's first law, M is equal to ZIT. Second law, M1 by M2 is equal to E1 by E2. Next we have resistance, R is equal to rho L by A. Resistivity is your rho, right? Resistivity formula will be what then? RA by L. Cell constant is your L by A. Then you have conductance, that is inverse of resistance 1 by R. Conductivity, kappa formula, that is your inverse of resistivity, so 1 by R into L by A. Then molar conductivity, kappa into 1000 by C. Okay, these are the formulas that you must revise. Okay, now let us go to the first question here. So this is Kohlrausch law question. NaCl, HCl and NaAC values are given. Find for HAC. Okay. So if you see lambda naught, first we'll write what? Given values. So 1 second, I'll start from this side. Okay. So what is the given value here? Lambda naught of HCl is given. NaCl, sorry. NaCl is given. Then lambda naught of HCl is given. Okay. Then lambda naught of NaAC is given. Okay. Okay. Now lambda of NaCl is how much? 126.4. And then lambda of HCl is how much? 425.9. Then lambda of NaAC is 91. Okay, write the units. S centimeter square mole inverse, S centimeter square mole inverse, S centimeter square mole inverse. Clear? Now what we can do? Now we will we need the value for HAC. Okay, so you first see where is H, from where we can get H, we can get from here. From where we can get AC, we can get AC from here. Now if you add these two, we are getting extra NaCl, right? NaCl is produced extra and we need to subtract that. So I will subtract this one. So what will be my formula? Lambda naught of HAC will be equal to lambda of HCl, okay, plus lambda of NaCl, sorry, 1 second, lambda of NaAC. Yeah, we have lambda of NaAC minus lambda naught of NaCl. Getting this one? Okay. So we have these values here. So now you can just substitute the values. HCl value is how much? 425.9 plus we have NaAC, that is 91, minus NaCl is 126.4. Now if you solve this, we will be getting around 390.5 S centimeter square mole inverse. Okay, so do not forget to write the units again. Okay, now let us see the next question. Calculate the Gibbs energy for the reaction at 298 Kelvin. Zn, okay, this is the reaction given to you and these values are given. This part is a theoretical question. I have already solved in the physical chemistry solution. You can see there. Now we will be discussing this one here. Okay, so you have to calculate the Gibbs free energy. So first of all, write down the given data. What is the given data here? Cell is given and you have E naught of Zn2 plus 2 Zn and you have E naught of silver plus 2 silver. Right? So Zn2 plus 2 Zn value is how much? 0.76 and silver plus 2 silver is 0.8. Okay. And now let us first calculate delta G, sorry, we need to calculate delta G value, right? And what's the formula for delta G? Minus NF E naught of the cell. So we need the value of E naught. So for calculating the E naught value, first we need to identify which is cathode and which is anode, right? So always remember, the one which undergoes oxidation is anode and the one which undergoes reduction is cathode. Now if you see, zinc is undergoing what? Oxidation. Right, so zinc will be anode and this one is undergoing reduction, so this is cathode. So I can write down, this is your it is undergoing oxidation, so this will be anode and this will be cathode. Okay, now if I want to calculate E naught of the cell, okay, so that will be what? First write the formula, E naught of cathode minus E naught of anode. Okay, now substitute, what is E naught of cathode? 0.80 minus E naught of anode is 0.76. So that will be giving me 0.04, right? We'll get 0.04 volt. Now we'll write the next formula, delta G formula, that is minus NF E naught of the cell. Okay, now if you see how many electrons have been exchanged here, Zn to Zn2 plus 2 electrons, Ag plus 2 Ag is 1 electron, but there are 2 Ag, so that will be also 2 electrons. So I'll get minus 2 into 96500 into E naught of the cell is 0.04. Now if you solve this, we will be getting around minus 3.301.08 kilojoule per mole. Okay, so just check this calculation and see the answer. Okay, now this is your rusting of iron answer. Fe will give you Fe2 plus first 4 electron and cathode, this reaction, reduction of oxidation, oxygen will take place. Okay, now let us see the next question. Calculate the EMF of the following cell. So again you need to calculate the EMF here. Okay, we'll use Nernst equation because concentrations are given. So directly we can write the first formula. E of the cell is equal to E naught of the cell minus 0.0591 by N log of, okay, what are the ions in the product side? You have Mg2 plus, right? Log of Mg2 plus divided by, and there is no other ion, and here I have log of Ag plus. Okay, and here you should not forget this 2. Okay, Ag plus square should be taken. Okay, now quickly substitute the values. E I have to calculate. E naught is 3.17 minus 0.059. You can take 0.591 also. N value is how much? Again here N value will be 2. Then log of, what is Mg2 plus concentration? 0.13. And Ag plus concentration is 1, 2, 3, 4, 10 to the power of minus 4 square. Okay, so now you have to solve this value and calculate the value of E. Okay, here you need log table. You need to ask your invigilator to give you log table. They will definitely give you. After that you can solve this question and you will be getting answer around 2.96 volt. Okay, fine. Next question, calculate the EMF of the following cell. Okay, this is the same question repeated. Okay, fine. Next question will go. Calculate the delta G of the following cell at 298 Kelvin. Okay, so this one I'll write it clearly here. This is like this. You have Mg plus Cu2 plus gives you Mg2 plus plus Cu. Okay, and E naught value of Mg2 plus 2Mg is your 2.37. Okay, and E naught value of copper 2 plus 2 copper is equal to 0.34. Okay, these are the data given to you. Okay, now let us see first of all what we need to calculate delta G. So before calculating delta G, we need to calculate E naught of the cell, right? And E naught of the cell is E naught of cathode minus E naught of anode, and you need to identify which is anode and which is cathode. How to identify? If you know which is undergoing oxidation, that will be anode, and which is undergoing reduction will be cathode, right? Now if you see here, this one is undergoing what? Oxidation, so Mg is anode. Okay, Mg will be anode. How I am saying this is undergoing oxidation? 0 to plus 2. Oxidation number is increasing, so that is oxidation. Now Cu2 plus 2 Cu, reduction because oxidation number is decreasing, so this is cathode. Okay, done. Now let us substitute here E naught of the cell. Okay, so E naught of the cell will be E naught of cathode minus E naught of anode, and here we have already designated cathode and anode, so I can write 0.34 minus, I have minus 2.37. Okay, this is minus 2.37. So what we'll get? We'll get plus value. So 7 plus 4 11, 3 plus 6 plus 7. So I'll get 2.71 volt, right? Let me check the calculation. Yes, 2.71 volt is the E naught of the cell. Now delta G value is how much? Minus NF E naught of the cell. What is minus here? We got N value is again 2, F is 96500, and E naught of the cell is 2.71 volt. Okay, now why I am saying N value is 2? See, magnesium to Mg2 plus 2 electrons will be required, copper 2 plus 2 copper is also 2 electrons is required, so N value will be 2. So correct answer after solving this you will be getting around 523.03 kilojoule. Okay, fine. Next question, a solution of nickel nitrate is electrolyzed between the platinum electrodes using a current of 5 amperes for 20 minutes. Okay, what mass of nickel is deposited at cathode? The molar mass of nickel is this one. Okay, so this question is from your Faraday's law, right? Whenever mass deposited question is asked, we need Faraday's law. So we'll write first the given data. So we have how much current? 5 ampere. So I'll write I is equal to 5 ampere. Time is how much? 20 minutes. You must convert it into seconds. Okay, 20 minutes means we have 20 into 60. So that is 1200 seconds. Okay. Next we need to calculate the mass deposited. So molar mass of nickel is given. Molar mass of nickel is how much? 58.7 gram per mole. Okay, done this one. Now we will write M is equal to ZIT. So Z formula again molar mass, okay, divided by N into 96500 into I into T. Clear? Now if you want to write like N value, see for nickel, if you see here, what's the oxidation state of nickel here? +2 state, right? So nickel will be in like this, nickel +2 will gain 2 electrons to give you nickel. So what is the number of electrons used? N value will be 2. Let us substitute here. So we will get 58.7 divided by 2 into 96500, okay, into I value is 20 amperes and time is 1200 seconds, okay. So if I solve this, I'll be getting around 1.825 grams, okay, fine. So direct formula based and easy question. Next question, the molar conductivity of 0.025 mole liter inverse methanoic acid is 46.1 s centimeter square mole inverse. Calculates its degree of dissociation given H plus, okay, methanoic H plus is 349.61 and HCO minus is 54.6. Okay, first of all, see what are the data given. Okay, so we need that molar conductivity of methanoic acid. Molar conductivity means lambda m is given for is a 46.1 s centimeter square mole inverse. Okay, and we need to calculate degree of dissociation. If you remember, degree of dissociation formula is what? Lambda m by lambda naught m, right? So I need lambda m value is given. Now I need lambda naught m value. So for lambda naught m, because it is a weak acid, lambda naught m of HCOOH will be equal to lambda naught of HCOO minus plus lambda naught of H plus, right? So I will substitute here. What is HCOO minus? That is 54.6, right, plus, and H plus is 349, sorry, it is 349.6. Are you getting? See, first we need to see what is the degree of dissociation formula. Lambda m by lambda naught m. From the question we have given, see, concentration data is given just to confuse you. It has no role here. Lambda m value is given, okay, lambda m value is given, and we need to find lambda naught m. And for lambda naught m, I have been given with the limiting molar conductivities. So we have to use Kohlrausch's law, add these two and get lambda naught m, then divide them to get the alpha value, right? So now let us add this one. So we'll have 6 plus 6, 12, here 1, 9 plus 1, 10 plus 14, then I'll get again 1, and 404.2 s centimeter square mole inverse. Okay, I'll check the addition once again. Okay, so we have 349.6 and then 54.6, so we will have, yeah, 404.2. okay, so now what I want, this is done. Now I need the formula for alpha. I'll write lambda m by lambda naught m, right? What is lambda m value? Already that is given to you in the question, 46.1 divided by 404.2. okay, now if you solve this, we'll be getting around 0.114. okay, so yeah, 0.114 is the value of degree of dissociation. Okay, fine. Next question will go, two electrolytes A and B containing solutions AgNO3 and copper sulfate respectively are connected in series. So this question is from Faraday's second law. Okay, a steady current of 1.5 ampere was passed through the solution until 1.545 gram of silver is deposited at the cathode of cell A. Okay, how long did the current flow? First let us solve this part, then we'll go to the next part. How long did the current flow? So now if you see, we have again Faraday's first law here, m is equal to, we'll write first the given data. Okay, first is given data here. Now if you see, we have steady current of 1.5 ampere. So what is I? 1.5 ampere. What is time? Time we need to calculate. How long did the current flow? We need to calculate. Okay, then how much silver deposited? That is, silver deposited is 1.45 gram. Clear? Done this one. Okay, now let us apply the formula. silver molar mass is also given to you. M of silver is 108 gram per mole. Okay, and how does silver gets deposited? Ag plus 1 electron give you Ag, right? So what is the N factor here? N factor is 1, right? Okay, now let us calculate here the formula. M is equal to Z into I into T. So Z formula is what? Molar mass. Molar mass divided by N into 96500 into I into T. Okay, done this one. Okay, now let us calculate. M value is how much deposited? 1.45 gram. Molar mass is how much? Molar mass is 108 divided by 1 into 96500. Okay, next current is how much? 1.5 ampere and time is T. So once we solve this, okay, once we solve this, we can find that time value will be around 864 seconds. Okay, you will be getting 864 seconds. Now let us move towards the second formula or the second part of the question. What mass of copper was deposited? Okay, copper mass is deposited, how much, that is asked. So for here, what's the formula? M1 by M2 is equal to E1 by E2. Okay, now what is this E1 by E2? E1 will be equal to, so I'll write with elements name so that it will be more clear. Okay, see, this one can be written like this: M of so we have M of copper by M of silver, okay, is equal to E of copper, means equivalent weight of copper by equivalent weight of silver. Now how to calculate equivalent weight? So that is equal to molar mass of copper, okay, divided by N of copper, and again molar mass of silver divided by N of silver. N of silver, okay, N factor means the number of electrons used. Okay, let us calculate mass of copper deposited. We need to calculate. Okay, mass of silver deposited is 1.45 gram, right? Already this is given. Next we have molar mass of copper, that is 63.5 divided by 2. Then molar mass of silver 108 divided by 1. Okay, so once you solve this and find the mass of copper, that will be around 0.42 grams. Clear? Okay, next question. The electrical resistance of a column of 0.05 mole liter inverse NaOH solution of diameter 1 centimeter and length 50 centimeter is 5.55 into 10 to the power of 3 ohm. Calculate its resistivity, conductivity and molar conductivity. Okay, so you should know all these formulas very well. Okay, so first of all we'll write the given data. What is the given data here? First is concentration, right? Concentration is how much? 0.05 mole liter inverse. Next you have diameter. So we need diameter is 1 centimeter. That means radius will be 0.5 centimeter. Okay. Length is 50 centimeter. And we have resistance. Resistance is 5.55. Okay, into 10 to the power of 3 ohm. Done. Next, first thing is to calculate resistivity. First thing is to calculate resistivity. Okay, so now for resistivity, what is resistivity formula? Rho, right? So if you know, we have written this formula, R is equal to rho into L by A, right? So that means what will be resistivity formula? Resistivity will be R into A by L, right? So I'll erase this one. So we got resistivity is equal to RA by L. Okay, so just substitute that. Yeah, so here resistivity rho is equal to R into A by L, where A is area. Resistance is how much? 5.55 into 10 to the power of 3. Okay, A value is how much? Pi r square. So we have 3.14 into area formula is pi r square into 0.5 square pi r square divided by L is 50 centimeter. Okay, so now you will solve this and you will be able to calculate the value. Next we will go for conductivity. So conductivity will be what? Just the opposite of resistivity, right? So I can say here, so if you solve this, we will be getting around 87.08 ohm inverse, ohm centimeter. Okay, so this is your resistivity. Now for conductivity, if you want to calculate kappa, that is 1 by rho. Okay, so you can just simply calculate 1 by 87.08 and that will give you 0.01148 S centimeter. Okay, S centimeter inverse, sorry. Okay, S centimeter inverse we will get. Opposite of this one, so ohm inverse, centimeter inverse. Ohm inverse is called as S centimeter inverse. Lastly, we will calculate molar conductivity, that is kappa into 1000, right, by C. So I already calculated kappa, that is 0.01148 into 1000, that is 10 to the power of 3, divided by C given is 0.05, right. Now if you solve this, we will be getting around 229.6 S centimeter square mole inverse. Okay, so we will be getting here 229.6 S centimeter square mole inverse. Okay, got it? Fine. Now let us see the next question. Calculate the Gibbs free energy change and equilibrium constant for the cell reaction. So we will be given with the Gibbs cell reaction and you need to find the Gibbs free energy. So Gibbs free energy already we know. First we know the formula E naught of the cell we need to calculate, right? That is equal to E naught of cathode minus E naught of anode. Now which is the cathode here? See, Fe3 plus is undergoing what? Reduction. I minus is undergoing oxidation. So Fe3 plus will be what? This will be cathode and this will be anode, right? Reduction will be cathode, oxidation will be anode. Clear? So we can put here 0.77, right? 0.77 minus 0.54. So I'll get 7 minus 4, 3, 7 minus 5, 2, that is 0.23 volt. Got it? Fine. Next we will find what? Equilibrium constant. So equilibrium constant, if you know, E naught of the cell is equal to 0.059 by N log of K. Okay, so E naught of the cell we already got 0.23. Okay, sorry, here we need to calculate. First delta G we need to calculate, right? We'll come back to this. First we'll calculate delta G value. Okay, so delta G value will be minus NF E naught of the cell, that is minus here N value. If you see this is very important, plus 3 to plus 2, 1 electron is required, right? And I2 I minus to I2 also 1 electron will be required, like 2 electrons will be required. So total N factor here will be 2, right? So we have 2 Fe3 plus, so 2, and here we have 2 I minus 2 I2, so total N factor is 2 here. F is 96500 and E naught of the cell is 0.23 volt. Okay, so after you solve this, you will be getting around minus 44.3 kilojoule per mole. Okay, next if you see, we also need to calculate equilibrium constant. So here E naught of the cell is 0.059 by 2 log of K, right? So we need E naught of the cell is already 0.23 into 2 divided by 0.059 is equal to log of K. Okay, once you solve this, you will be getting 7.79 as log of K. Okay, now for K you need to take anti-log. Okay, so K value, if you take anti-log, that is 10 to the power of 7.79, that is equal to 10 to the power of 7 into 10 to the power of 0.79. Anti-log I told you yesterday how to check. So I have made a video on how to check the log and anti-log table. So you can check there. You will getting 6.16 into 10 to the power of 7. Okay, that will be the value of K. Clear? Fine. Next question, calculate the EMF of the following cell and state whether the cell is visible or not. So remember, if your EMF is coming to be positive, then the cell is visible. Okay, if E of the cell is positive, then it is visible. If E of the cell is negative, then it is non-visible. Okay, so here direct Nernst equation we can use. E of the cell will be equal to E naught of the cell minus 0.059 by N log of Okay, here you need to see the equation. So if you see, here is what it is undergoing, oxidation. So I'll write the equation here. So Br minus 2 Br minus will get Br2 plus 2 electron, right? This is at anode, reaction at anode, and then the reaction at cathode. Reaction at cathode will be what? 2H plus, right? Gaining 2 electron to give you H2. Now if you add these two reactions, this one will get cancelled, will get 2 Br minus plus 2H plus gives Br2 plus H2. Okay. Now if you see, we'll have log of, so what will be log of pressure of Br2 and H2 divided by concentration of Br minus, and let me write it clearly, one second. Okay, see here, we will get, this is anode reaction, right, and this is cathode reaction, right. So I'll get log of pressure of Br2, pressure of H2, Br2 pressure of H2 divided by Br minus ion concentration to the power of 2, because this 2 is there, then H plus concentration to the power of 2. Okay. Now if you solve this, what is E naught value? E naught value is already given, 1.09 volt minus 0.059 by N is 2 here, number of electrons used is 2, then log of pressure of bromine is 1, pressure of this one is also, so bromine is liquid, right, so no need to take its pressure, hydrogen is 1 bar, then you have Br minus concentration is 10 to the power of minus 2, okay, square, and then divided by H plus concentration is 3 into 10 to the power of minus 2, okay, and its square. Okay, so now if you solve this, okay, you will be getting E naught value as minus 1.29. Okay, and since this is a negative value, you have to write cell is not feasible. Cell is not feasible. Okay, fine. Next, okay, now calculate the limiting molar conductivity of Cl minus by using the data. Okay, so here if you see, again Kohlrausch law question, so we have lambda of CaCl2 is equal to lambda naught of Ca2 plus, right, plus 2 times of lambda naught of Cl minus. This is what many of you make mistake, you do not take this 2. Now what are the given values? First let us write down lambda of CaCl2 is how much? 271.6 s centimeter square mole inverse, right. Then lambda of Ca2 plus is how much? 119.0 s centimeter square mole inverse. Okay, so we just need to calculate for this one. So calcium chloride is 271.6 and calcium is 119.0 plus 2 times of lambda naught of Cl minus. After that you will solve it and you will be getting lambda naught of Cl minus as 76.3 s centimeter square mole inverse. Okay, so that is the question. Next question, say calculate the potential of hydrogen electrode in contact with a solution whose pH is 10 and the partial pressure of H2 is 1 atm. So when you is asked to calculate the electrode potential, okay, it's always asked to calculate the reduction potential. So what is the reduction of H2? 2H plus, so I can write like in terms of only one H plus plus half, sorry, one second, will get like this, H plus plus 1 electron gives half H2, right. So now if I write the reduction potential, E of the reduction potential of H plus to H2, E of H plus to H2 is equal to E naught minus 0.059 by N log of P of H2 by concentration of H plus, right. Now let us substitute this value, this is 0 minus 0.059 by 1 log of pressure of H2 is what? 1 atm and H plus concentration. Okay, here you see pH value of H is given. That means what? What is the H plus concentration? H plus concentration is nothing but 10 to the power of minus 10, right. So I will substitute here 10 to the power of minus 10. Now this one will go up and if you multiply you will get 0.59 volt. Okay, so correct answer will be minus 0.59 volt. Okay, very easy question, NCERT question. Okay, next, calculate the cell potential Kc and delta G for the reaction. Okay, first of all, to calculate the cell potential, you need E naught of cathode minus E naught of anode. So here you see chromium is undergoing oxidation, so this is anode and this is cathode, right? So first we will calculate the first part. E naught of the cell is equal to E naught of cathode minus E naught of anode. I'll substitute the values. Cathode is 0.4, right, minus 0.74. So how much we'll get? 1.14, right? I think that is correct. Yeah, we'll get 1.14 volt. Next, Kc value. So if you see, what is the formula for Kc? E naught of the cell is equal to plus 0.059 by N. So N is N. Okay, here N you need to be very careful. See, chromium, 2 chromium 3 plus 2, 3 electrons are used, but how many chromium are there? 2, right? So that, suppose if I write this reaction, see, Cr2 Cr3 plus 3 electrons, okay, and if you see cadmium 2 plus 2 electrons is cadmium, right? So to balance out the equation, we need to multiply this one with 2 and this one with 3. So the number of electrons used will be 6 here, okay. So N factor is important. N factor is 6 and log of K. So you have to substitute this. So first we will write the formula, right? This is formula. We cannot substitute here. We will substitute again. Now E naught of the cell is 1.14.059 by 6 log of K. Then first you need to find the K value, then you need to take the anti-log. Now coming to the next part, that is delta G. Okay, so coming to delta G, so that is also very easy. Just you need to substitute the formula. Delta G is equal to, third one, if you see, delta G is equal to minus NF into E naught of the cell. So what is minus N here? N is 6, F is 96500 and E naught of the cell is how much? 1.14 volt. Now if you solve this, we'll also be able to calculate the delta G of the reaction. So you can see here 0.34, one second, did we do any mistake here? CD2 plus, okay, this value is minus 0.4, sorry, this is minus 0.4, so it will become plus, so here is a small error. Okay, one second, this one is, okay, just a minute. This value is minus 0.4, right? So I'll get minus 0.4 plus 0.74, right? So that will be equal to 0.34. Okay, we'll get 0.34 volt. So here also we need to change here 0.34 and here also we need to change. Okay, please correct this one. We'll get 0.34 and here also we'll get 0.34. Okay. So once you solve this, you will be getting these values. Check the calculation once again. Okay, fine. So students, that was a lot of numerical practice regarding your physical chemistry last part E 3-marker questions. So please revise these questions, revise the formulas and do these calculations again, do these numericals again so that you can master them. Okay, all the very best for your midterm examination.